everyone. Welcome to the 100 Day System Verilog Challenge, and this is our day 3. I am your host Kittu Patel, and today we will see the structure and union which was there in System Verilog in detail. So let's start the video. Now, these are the agenda which we are going to follow today. So we will see the theoretical aspect of structures and union, and then we will also see some example using coding. Okay, so we will also deliver some coding part so you can understand it well. Now see, what is a structure? So structure is basically a user defined data type which is used to group a variable of different data types. So suppose see you have some different type of variable and you need to use them combinedly. So instead of writing there individually, you can group them. So by using grouping, we can increase the code reusability. Okay. Now it is similar to structure in C or C++. So here you can see the example. Here I have considered one structure which is named as student info, and here I have collected three information, whereas first one was string name and the another one was email and the last one was mobile number. So see here I have collected a variable which is of different data type. So here you can see our name is of string data type, whereas our email is of also string data type, whereas our number or mobile number is of int data type. So here we are accumulating all these three in a single entity, or you can say we are wrapping a whole entity in a single one. Okay. Now let's see how can we access structure entity. So here I am accessing structure element by using instance. Okay. Now here you can see our instance is student info. So I am just writing student info and the element is name. So student info dot name. So by using dot operator, we are accessing the element. So student info dot name is equal to Vaibhav. Okay. Now similarly like that, we are accessing our email elements. So student info dot email is equal to my email. So that's how you can also able to access the structure elements. Now keep this in mind. Your each structure member or each structure element has some separate memory allocation. So see here your name will get there's individual memory location, your email will get your individual memory location, and your mobile number will get some individual memory location. They will not share their memory location between them. So each one will get individual memory location. And also keep this in mind, your structure is static and also synthesizable or called for hardware modeling. Now let's see the size of structure. So here you can see that our bit is of 4 bit and here it is of 8 bit and here it is of 16 bit. So the total size of this structure will become 4 plus 8 12 and 12 plus 16, which means 28. So here the size of your structure is 28. So that's how you can calculate your size of structure. Now see, these are the benefit of structure. It will increase your code readability, or you can say it will improve your code readability, because here you are not using single variable for every time. You are just clubbing all the variable in a single one and you are using that wrapper only. So it will improve your code readability. It will promote reuse. So whenever you want to make some changes, so you can only have to do in the structure. Okay. It will also easier to manage and maintain. Now let's see the practice. So let's do some practice. Now let's do a practice to see the structure clearly. Now here you can see I have opened my EDA playground. Now let's write a code to see the structure clearly. So let me write. So suppose declare a module. So module name is TB and end module. Okay. Now declare one structure. So I am writing type def. I will also explain in my further video why we are using type def. So type def right now and struct. Okay. Type def struct, and let's consider. Okay. So let's consider one parenthesis or bracket, curly bracket. Now let's write some data. So int, or you can say bit 3 down 0. Bit 3 down 0, a is equal to 4 tick b. Okay, or 4 tick has 5. Okay, so I have considered one hexadecimal number 5. Now let's consider 8-bit variable. So just here write 7 and here 5 4. So that's how we have considered, or 5 4 let's say 44. Okay. Now let's consider one 16-bit variable. So 16-bit variable. So here we have to write it. So we have written it. Okay. Now consider 16-bit variable. So 16-bit variable 8917, and let make them some different names. And the last we are considering 32-bit variable. Okay. So see here we have considered 4 different variable which is of bit data type, and we are assigning some different value. Now here we have to write 16, and here we have to write 32. Okay. So 32 down has, and let's say 1 2 3 4 5 6 7 8. So here we have considered four different variable, and the value for first variable is 5, the value of second variable is 44, and the value of third variable is 8917, and the value of fourth variable is 1 2 3 4 5 6 7 8. Now let's take an instance of this structure. So here write some name to consider one instance, my struct. Okay. Now let's take initial begin block, initial begin end. Okay. Now let's take an instance, so my struct, and so write some name. So I am writing m1. Now let's give the value to each variable. So m1 dot a is equal to, and since we have already given the variable, so let's try to access them all. So dollar display percentage 0h, percentage 0h, percentage 0h, and percentage percentage 0h, and also percentage 0h. Okay. So I have written the 4 access modifier to access that structure element. So m1 dot a, m1 dot a, m1 dot b, m1 dot c, m1 dot d. Okay. Now we have written, so now we have taken instance of each one. Now let's run the code. So here you can see our each variable is getting their appropriate value. Now a is getting 5, b is getting 44, c is getting 8917, and d is getting 1 2 3 4 5 6 7 8. So keep this in mind, your each variable are getting some individual memory location or separate memory location. Now let's learn union. So see, what is a union? So union is also a user-defined data type which is used to similar like a structure, but only one key difference was there. So your each variable will share some common memory location. Keep this in mind. In the structure, we are getting some individual memory location for each of our variable, but here in union, our each variable are sharing some common memory location. What does it mean? So your only one member can hold a valid data at a time, or you can say only your one member can hold a valid value at a time. And you can also say your memory allocation is equal to the largest member size. So suppose in last example we have the largest memory allocation for variable d, which is of 32 bit. So that allocation will be considered as the real memory, and the else variable will access that memory. Okay. So that's how your union will work. Now this is the syntax of union. So here we have defined a keyword union, and here we have taken the data type name. Okay. So what does this do? So see, all our 3 member word, Harvard, and byte share the same 32-bit memory. So see here the maximum size of memory is 32-bit. So all these 3 variable are shared common memory. So you can if you are making changes in one, so the changes will reflect in the another one. Okay. So that's how you can understand union. So what are the application of union? So when you use union in SystemVerilog, so when you want to view your data in modified way or same data differently, so that's from that point of view you can use union. Whenever you are protocol decoding, like whenever protocol demanding some union kind of thing, so you can use. Also you can use your union in hardware modeling and also interpreting memory mapped register. Okay. So these are the few application of union. Now let's see their application by using coding. Now let's see the application of union by programming. So let's comment it out. Okay. So here we are commenting our code and take this code from here only. There were little bit modify in this code. So see, here in place of struct you have to union. Okay, in structure you have to write a keyword struct, but in union you have to write keyword union. So in place you have to replace with union. Okay, now let's consider not give value or not assign a value. Okay, so we are keeping our variable uninitialized so that we can give the value afterward. So now 3 down 0, this is a. Okay, now let's start assign value from here. So m1 dot a is equal to 4 down has 2, let's say. Okay, now next after this display we are giving m1 dot b is equal to 4 8 down has 3 4. Okay, now same thing, same display goes over here, same display goes here. Now m1 dot c is equal to 16 down has 4 5 6 7. Okay, now same display goes here. Now let's take this same. Now m1 dot d is equal to 32 down has 5 6, let's suppose 1 2 3 4 and 5 6 7 8. Okay, so we have assigned the value to each variable. Now let's see the result, and the result are little bit shocking for you. Okay, so let's see the result. So here you can see here we have assigned value only to a and the rest will uninitialize, but still they are getting value 2 2 2 2. What does it mean? Your each variable are sharing some common memory location. So you are assigning 2 to a, but it is going to the memory location of the highest bit, that is 32. So here it will store 2 and then rest will get the same memory location, or rest are sharing the same memory location. That's why you are getting 2, and that you are assigning 34. That means you are overriding 2, because it see each memory because see your each variable is using some common memory. So whenever you are assigning something which is of higher bit than previous one, so it will get overridden or overridden. So here you can see you are getting 34 34 34, and since a has the tendency to hold only 4 bit, so we are getting the last bit of 34, which is 4. Okay, and similarly like this here we are assigning 5 6 4 5 6 7. So here we are getting 4 5 6 7 4 5 6 7, and since b has the tendency to hold only 8 bits, so we are getting 6 7, and a we are getting 7. Okay, and here we are assigning 1 2 3 4 5 6 7 8, so we are getting, and since c has the tendency to hold only 16 bits, so we are getting 5 6 7 8, and b are getting 7 8, and a is getting 7 8. So this is how you can say that, like in union we are sharing some common memory location, and once we are writing some value in the union, so the our previous value will get overridden. Okay, now let's see the difference between structure and union. So see in memory allocation, so in terms of memory allocation, your structure will separate, or your each variable in structure will get some individual memory location, whereas union share a common memory location. Now size. So size of your structure will the sum of size of each data types, whereas the size of union is the size of the largest member only. Now accessibility. All member can be accessed and held simultaneously. We have seen, and here your only one member is valid at a time. Okay. Now use cases. You group different data types of related variable, and for union view same memory in different formats. Okay, now what is their example? So modeling a register with multiple field in structure and typecasting data in union. Now data lifetime, your each member keep its own value. We have seen in coding also, like our each member in union are getting their individual value, whereas in also we have seen in the example also, like our each member keeping its own value in structure, whereas in union the value will get override. Okay, now this is the declaration syntax. We have already declared it, so it is not need to be explained, and both are synthesizable. And default storage type like member placed in order of declaration, how much member we have placed, so according to the size declare. And the union, all members start at same memory location. Okay, this is the syntax. And data view, each field is independent, that means your each variable is independent, whereas in union single data interpreted in multiple ways. Okay, now for this is all for our today video. I hope you have liked this video. If you want to be a part of this series, then subscribe this channel and make sure hitting the bell icon so that you will never miss the update. Thank you.